Hey guys, Wadox Studios here, and today's question comes from the Oculus Start Discord, pretty good friend of mine, and we were just, long story short, we were discussing components, and in this particular case, friend of mine is really used to using Blueprint, and um, while discussing modularity with components, it came to my attention that I haven't gone over this, so today's going to be like a Dev 101 session, right? So, um, like to approach the engine like if you were coming in new, and maybe you've played around with it in level design or like, some other way. But let's say you want to get into development. Um, so you would install an engine version up here from the launcher, and also right here underneath, you'll have a place to manage plugins. Usually it comes with Quixel Bridge by default, and then it'll list any other installed plugins. But most people don't know you also have these components that get installed, as well as like starter content, engine source, editor symbols. But if you want to do Android development, mobile development, you'll need to enable that target platform so you can get things like Android Preview. Now, when you hit launch, you're going to load up like the template. It's basically a place for you to get like a really quick start or even pick a blank project. But you'll notice you'll have like some target platform for desktop or mobile and quality presets. Now, your quality preset is going to be your scalability in the realm of the RHI that you're targeting. So if you want, you can go to a previous video I've done. I'll have it in the description where I kind of talk about stepping backwards from DirectX 12 to 11, from SM6 to SM5. But yeah, I do a whole another talk on that. But this is only important if you're targeting mobile and you want to get to the quickest place to target mobile. I would say pick it here. If you're targeting desktop, you're still gonna be in deferred by default, just because that's what Unreal Engine considers desktop to be. So go check out that video on how to change back to forward. It's not a complicated process, but it'll keep most of your stuff enabled and allow you to work in desktop, but in a cheaper rendering pipeline. The other thing is the Blueprint and C++ thing here. If you're new to Unreal Engine, I would recommend sticking with Blueprint. However, it doesn't really matter what you decide here. What this really is gonna determine is how your base classes operate. So if you're in a C++ project, your base classes are gonna be all C++. If you're in a Blueprint, it's gonna include like your character blueprint class and your game mode blueprint class as blueprint. But I'll show you in a second. You can always also incorporate C++ into your project. So we'll just get started here. I'll pick a location, and we'll just name this Development 101. And you'll notice I started with like a blank project. I don't have really anything in my content folder, but I also still have this map. The reason I did this is to show you guys that you can always add in feature packs later. So even if you're on a third person and you want first person stuff or mobile stuff or whatever, you can always add it in later. You can always add content in later. And then if you have the Fab plugin, you can always grab stuff from Fab. But we're just going to add the third person stuff to the project, and we will go to that map, load it up. And this is a really good segue into talking about your project settings. Now, in the blueprints folder, most tutorials are going to start you out with this like, hey, let's go make a blueprint. Let's make a blueprints folder in the content directory. And we are going to do that. But for a different reason. So this comes bundled with the third person and character blueprint and the game mode. And if you look inside of the maps world settings, you'll see that the game mode that is set over here is set to those things, so that whenever you hit play, you load in. Now, let's talk about what's happening here. The game mode has a event, even though you can't see it. If we go in here, we go to full blueprint editor, there's nothing in the event graph, etc., etc. a blueprint class is deriving from a parent class, which is at the C++ level. It has code that it's doing essentially right now. Handle starting new player is being fired, and then it calls basically, if this was a child you would see it, but it's calling the parent function like this on the C++ class. If I was to override this or just leave it doing nothing and we hit play, you'll see I don't spawn anymore. So that's a little bit about inheritance. You can always make a call to the parent function, or you can override a child. Even though this is a BP, it's still inheriting from this game mode here. Or if we blow this away completely, it's just going to naturally do that parent call because we're not overriding by putting the event in here. So that's that. Let's talk about a little bit about like what the game mode is. As you can see, it's attached to a map, and the game mode is going to be a place where you want to do all of your, like, is this a death match? Is this Slayer? Is this a single player linear level? That's what your game mode is going to do. We're going to make a new thing called a game instance. And by default, a project is just going to use the C++ class for game instance. But because the game instance is a very, very, very important class for you, it basically is the only thing outside of like a subsystem that, because a subsystem is inherited from, like, it's a game instance subsystem, it works a lot like a game instance. A game instance is a thing that is going to persist throughout your application. So doesn't matter if you destroy your actor, doesn't matter if you destroy your controller, doesn't matter if you change maps and your game mode changes. The game instance is going to be a consistent place across the entirety of your game where you can store information that you want to persist for the lifetime. So a good example of that would be you could stash your save logic here. Like, so if you want, which your save logic could be done in the game mode if you want it to pertain to each game mode and have its own thing. But I would say that, like, you pass the game save object into the game instance and you would have one location to basically handle the saving logic. So you would come into your game instance, you would do like add a custom event, and you would just be like handle save. And then here on an input is where you would like create the thing, save object, and then let's say save. We don't want the class, we want the object. And then you would just pass this in, and for now I'm just going to print it. And this would basically take in your save object and then handle your saving, which you do, you know, you have save game to slot that you can call, right? So in your game mode, right, some event would happen and you would be like, you would call and remember, you have inheritance here, so you can do a child of this and then override the object that you're going to pass into the game instance. So if we call save game mode from the game mode, and that would technically be save game mode data, you get the game instance, cast it, or you could use interface. And then you would call the function. And then here you would pass the save object. In each of your, like, so say this third person game mode, we created a save object variable. right? And that would be here. You would just pass this object into the function call. And if we created a child of this, if we go over here and create a child blueprint class, this could be BP Slayer or something like that. Ignore my misspelling. And then we hit compile and save. On your view mode here for inherited variables, you should now see the save object, and you can change it here on the child class. So this is an easy way for you to swap game modes between maps, and then you still have access to like your class defaults for like maybe you want this Slayer to have a different controller, or maybe you want this game mode to have a different pawn class, or maybe you want the spectator to behave differently. That's how all of this is related to each other. Now, your game state has a unique thing. Your game mode has a unique thing called a game state. You can get game state. The game state has things like player index, player array, things that respawn delay, respawn time. It has things that are unique to the game mode, but also quantify or keep track of different things. Like if you wanted to, instead of storing kills on the player controller or storing kills at an instance level across all game modes, like total kills across the whole session of the game, you could store this in your game state for each game mode, for like say Slayer or Deathmatch, etc., and get game state cast and get the kill for each player array. So like you could do for each and then look it up. You could also store that in the player state, but that's how each of those things are related. In the world outliner, you'll see most of this is basically gonna be a drop down that you can select, and then in the project settings under map and modes, your default game mode is where you would set this, whatever your default game mode is going to be. And then same thing with like, we don't want this to be this. It needs to be like third person map by default. And then later on, you can set up aliases for each one of these game modes. So you can do like a class alias. You can call it something. You could be like, this is Slayer, if you want to look it up that way. And then you would select your BP. So just a little tidbit there, a little hint about how you could potentially get a game mode class by alias, or even like load a level and pass in the game mode's alias to load the right BP. So that's that. More into like modularity. So as you can see, a BP derives from a C++ class. The C++ class is essentially the same thing if I was to take this actor and drag it out into the scene. Over here, you'll see you can't do anything with it. But if you look in the details panel, you'll see that you have components here. Now, what if I wanted something to maintain health, or something to play a sound on objects that existed in the scene, but I didn't want to have to create an actor blueprint, and we'll do that. BP actor. And then we drag this out here. You'll see it's the same thing, but now I have code. So this actor doesn't have code. This BP actor that derives from actor does have code, and I can go edit this behavior, right? But say that an actor class is built up of components, and say that we want to do something to these C++ actors that are out in the scene, and I don't want to have to make a BP of every actor that I want to do logic on. And we know that actors are made out of components. So like, if I wanted to, I could pick this thing that's in the scene. Like, let's just, we'll make a shape. We'll pick a cube. We'll drag it out here. And if I go to the right here, you'll see like in this submenu for this cube, I can add components right here, right? Which expands the capacity of what this cube can actually do. We can add a sound to it. We can add another static mesh to it. We can add a skeletal mesh to it, a point light, etc. If we add a point light, I can now go to this point light and I can offset it, right? And that's all on this C++ class, which I don't have a lot of freedom in code, but I do have parameters that are exposed. And these parameters have been set up in that components class. So just like you can derive and expose code for actors, you can do the same thing. If we go to the blueprint class and we do point light, and there's an object here, that's an actor. But look at here, you have a point light component. So if I select this, I could do BP point my for whatever reason my keyboard didn't want to type point light comp. And now if we double click it, you have an event graph, and you can make modifications to its behavior. We can say on begin play for this component, we are going to get the owner, which this is the owning actor of the component, and we're just going to print. That is not what I wanted to do. Print. So like we're going to print the display name of the actor on begin play that this component is attached to. So right here, I'm going to remove this point light from the cube, and then I'm going to drag this thing that I just made, which is basically a child of the point light class with my own custom logic to it. And then we're going to hit play, and you're going to see that cube is printed. So the same concept can be said where you can add custom logic to things like sound. You can get the owner, you can get the angular velocity of the actor, or you can get the linear velocity of the actor, and then you can basically have a universal sound class that will pitch and change the volume of the sound component based on the movement of the parent. And that makes it very modular, so because you can now apply it to actors that are both in your scene, but then if you have an actor that you want to use it on in Blueprint, you can also get your BP point light component and use it on your actor blueprint as well. And again, inheritance works here too. So if you want to override or derive functions, you can make a child of this blueprint class and specialize it even further. So yeah, hopefully this kind of goes over that relationship of how, you know, actors and components work together, but also how parent and child inheritance work, so that you can be a lot more versatile and work within your scene and work within your world outliner without having to make a bunch of different actors and child actors. Because what you really want to do with inheritance is you want to make a base actor of some type that has some control at the top level, and you want it to be derivative of the closest thing. So like if I knew that I wanted an actor that was always going to be a static mesh and I wanted to have specific behavior, then I would derive that class from a static mesh actor. So this would be my BP static mesh actor. Now, what I would not do is apply anything to the mesh value here, because this static mesh actor could have logic on it, or could have children that you could set up prefabs for. So this the parent actor could essentially, if we go to the level prototype and we go to mesh, the parent actor could essentially have this cylinder applied to it. But then if I drug the static mesh actor out again, or copied and pasted it, so yeah, that's probably a good way to show this. If I copy and paste this, you'll see it's another cylinder. But while it's in the world outliner, because it's a static mesh actor, it technically can be set to anything. So this static mesh actor can turn, like, even though they're both the same parent class, it can basically be this shape instead of this shape, because at the end of the day, it's still a static mesh actor. The other thing is if you want to store prefabs of different shapes and you don't want to have to change this individually, and you want to be able to drag these things out really quickly, then what you can do is the parent here can be set to some static mesh like this one. So that will now be the parent behavior. And it is essentially a prefab. So you'll see it here, right? And if we come here and I hit this back button, it's going to revert back to its defaults. These two are the same, but you'll see this one is not. If I reverted it, it would go back to the cylinder, but I can always override it at the property level. Well, the other thing you can do is create a child of this blueprint class, and then you can make the child what you want it to be as far as your mesh is concerned. We'll just do this cube. And now you have a say to BP that is a child of your blueprint class, and anything you do in your event graph here for like event, we'll just do this. Anything you do here will happen across every instance that's in your map. Parent example, right? Now, I don't want to keep confusing you with this, so I'm going to get rid of this light component in this actor because we were printing out a couple of things. There's also something else in the scene that has a light component on it, which is this cube here. We'll get rid of that. So we have a parent example, both of these guys, right? So we will delete this, we'll drag a child. We get the same thing, parent example. The child still runs the parent's instructions. But then on the child level, you can always come in here and go, I don't want to run the parent begin play. I want to do something different. And now you have hello with parent example. So this is firing parent example, this is firing hello. Then on the child as well, you can say, okay, well, I do want to call to the parent function, but I also want to do something in addition to what the parent does. Hello, parent example. So that's the versatility of inheritance. I think that just about covers most of the Dev 101 and the versatility that, you know, this class structure and inheritance structure and component structure has. One of the things I do want to make note about is, like, while I'm here, this should be development 101 for everyone, and a lot of people don't know this as well. If you have a ghost tick, it's not technically doing anything, but the actor is still going to be ticking by default. And that tick does add to the tick queue, or what's called the tick pool, and it will be a little bit of overhead. If this tick isn't wired up, you can uncheck this box and save a little bit. You can also change your project settings and set everything to not tick. And then that will force you to turn this on for everything. But the same is also true for components. Components themselves, as you saw, have a tick function. And if you look at the, if you've inherited from a C++ class and made this a blueprint, then you can right click this and edit it, and you can see whether or not the tick is available for you in the component. And if this tick is not wired up to anything, and we'll just do comp ticking. If this tick is not wired up to anything, it means you don't have to tick it. If it is wired up to something, I don't think we have. What is this? BP actor? Yeah, we don't have it in the scene. But if it is, it's right here. It's ticking. So if it is wired up to something, you're going to need it ticking. But if it isn't wired up to something, if it isn't doing any logic at all, each component that's on an actor needs to, if you want to save everything that you can, not be ticking as well, because that also adds to the tick pool or your overhead. If we hit compile here, now you'll see I'm not ticking that out anymore. So remember to smack that like button and that subscribe button if you like the content that you're getting from this channel. I do want to say thanks to everyone, the Wild Ox Studios family, those of you on the Discord, and those of you that are reaching out through other Discord channels like Oculus Start or Unreal Engine Source. Keep the ideas and the questions coming, because it inspires me to continue to make content like this for you guys. Have a wonderful day, and until next time, toodles.